Okay, so welcome everyone to another science video lesson. And on this lesson, we will going to tackle chemistry. And there's one part of chemistry which we will going to discuss today, which is very important, and that is the preparation of solution. Okay, so how do we prepare solution? What are the basic things about solution? And what is this percent by volume? What is this percent by mass? So all of them we will going to discuss here today in our science video lesson. So let's check it out. Okay, so okay, so here we are in this presentation that we have right here. And if you are familiar with this in this diagram, okay, this is the classification. All right, so this diagram is all about the classification of matter. All right, so under this, you will be able to see how matter is classified into different entities like mixture, pure substance, compound, element, or even a solution. Right, so if you're going to start first, or to start classifying matter in terms of uniformity, there is what they call heterogeneous mixture, and we have your homogeneous mixture. All right, so and also there's another one. If you take a closer look at its variable composition, if it is variable, that is a solution. If if the matter doesn't have any variable composition on it, and that is a pure substance. All right, and a pure substance which can be separated is called compound, and the pure substance which you cannot separate by any means is called an element. All right, so but we will not discuss these entities here. We will just focus on one group of one classification of matter, which is called the solution. All right, so what is a solution? So that is our lesson today. Now, if you already if you happen to prepare a tea, all right, if you happen to prepare a tea or a juice drink, okay, probably you have encountered already this solution. All right, so how does the solution, okay, so how does the solution differ from any other classification of matter? All right. So what is a solution? Okay. So what is a solution? Okay. Types of solution, concentration. What's that all about? Okay. So okay, what is a solution? A solution is a homogeneous mixture of one substance, all right, that is dissolved to another substance. Okay, so we call that substance that is dissolved to another substance, it is called a solute. All right, and the one that dissolves the solute is called the solvent. All right, so in a solution there are always two entities, the solute and then the solvent. All right, so the solute cannot exist on its own, or even the solution cannot exist without solute and solvent. So these two entities that we have right here, the solute and the solvent, is very important. All right, next one. If you manage to get the ratio or to get the amount of solute and solvent that you are going to use in a solution, you are pertaining with concentration. Alright, so whether the concentration of solute is greater than the concentration of solvent or vice versa. So the ratio between those two entities that we have right here, the solute and then the solvent, is called a concentration. This is very crucial in preparing solution. Now, if you want a concentrated solution, you must check out the ratio of solute versus the solvent. Alright, if you want your concentration, or if you want your solution to be diluted, alright, there is a certain ratio that you need to prepare between solute and solvent in order to achieve what you need in terms of preparing a solution. Alright, so that is what solution means. And don't forget, solution is made up of solute and solvent. Alright, so there are different types of solution, not only in solid and liquid, but also in other types of or other state of matter. Now, what we have right here is a gas and gas. A gas is the another gas is solvent, and the other gas is solute. Very good example of that is the air we breathe. All right, the air we breathe is not pure. All right, it contains several gases like nitrogen, carbon dioxide, oxygen, argon for about 0.0 something percent, okay, methane, okay, and a lot of things. Okay, so we have natural gas. All right, so we have oxygen acetylene mixture for welding, something like that. Okay, so that is gas and gas solution. So we have a gas and then the liquid, in which the liquid here is the solvent and the gas here is the solute. Example is the carbonated drinks. All right, so example is the Coca-Cola. Right, so if you happen to notice, the liquid dissolves, the liquid or the water in there is your solvent, and the one that is dissolved on the solvent is your carbon dioxide. Alright, the other one is liquid. So example, juices. Alright, if you want to dilute juices. Alright, next one, alcohol in water. So if you want to prepare a 70%, 80%, 60% alcohol. Alright, so this is the type of solution that you have right here, liquid and liquid. Alright, there's another one called solid and liquid. So the most familiar one here, we have sugar in water, then salt in water, you have calcium chloride in water, and so on and so forth. Alright, next one. We have solid and solid. So, alright, so we have solid and non-solid. So, if you want... Alright, so I have a question here. How do you be able to mix two solids together? Alright, so if you have the answer, just put it down in the comment section. So the question is, how do you mix two solid together? Alright, how do you create a solution of solid together? So we have here an example: steel, brass, we have stainless steel. Alright, so stainless steel. Alright, and many more. Okay, next one is gas and solid. The example here is marshmallow. Okay, so in which the solid here, alright, so the solid here is your solvent, and the gas here is your solute. Okay, so these are the different types of solution that you might encounter in your daily life. Okay, next. We have different kinds of solution. Alright, it can be number one, it can be saturated, or it can be unsaturated, or it might be super saturated. So what is the difference between the three of them? Alright, so the first one, the saturated solution, this is a kind of solution in which the solute is dissolved. Alright, which is normally it is done by in a solution. A solute is dissolved in a solution, but there are undissolved solutes. All right, there are undissolved solute that are found in your solution. For example, if you want to make a Kool-Aid drink, all right, if you want to make a Kool-Aid drink, right, so you put some tablespoon of that juice, and if you notice that there are some sugar particles that are not dissolved yet on the solution. All right, so that is saturated solution. Okay, the next one is the unsaturated solution. So this is a kind of solution in which the solute is completely dissolved in the system. Alright, so the solute is completely dissolved, leaving no remaining substance behind. Alright, so that's the unsaturated solution. Next, the third one is a supersaturated solution. Now, this is a saturated solution. Alright, so this is a saturated solution, but on one particular thing. It has more solute than the saturated one. Alright, it has more and more solute. If we will give it a value of 1 on saturated solution, this has 3. Alright, this has 3. So it means that since you have more solute than solvent, the tendency is that the solute will crystallize in the process at the end of the day. Alright, this is true in some processes in making candy. Alright, in making powdered juices, something like that, crystallized juices. All right, so supersaturated solution is the process or the kind of solution that they use. All right. So to better visualize this one, let's have it right here. Okay. So we have it. We have this picture here of a saturated solution. As you can see here, the water, which is the solvent. All right. So we have the solvent here, and we have the solute over here. All right. Now, in some cases, the dissolution process or the dissolving process is the red arrow, and the blue arrow is the crystallization process. Okay, so what do we have right here? If you happen to see the red arrow, all right, the red arrow is greater than the blue arrow. So it means that the solute is being dissolved faster than it has the ability to crystallize. So the blue one is the ability of the solute to crystallize. So in this case, to make it a saturated solution, the two of the arrows, the dissolution or dissolving arrow and the crystallization arrow, is somehow in the same what do you call that? In the same magnitude. All right, in the same magnitude. So what happens here, the solute will not be dissolved totally in your solvent. So there will be a solute remaining on the solvent at the end of the day. All right, so what we have right here is the second one. We have the supersaturated solution. So in this type of solution, we have a lot of solute. Alright, so we have a lot of solute versus the solvent. So as you can see on the picture. Now, it has greater dissolving, or the solvent has a greater magnitude of dissolving process, or dissolving has a greater process of dissolution. And since there are more solute in the system than solvent, there are greater chance of having or forming a crystals at the end of the day. So at the end of the process, on this figure 3.3, as you can see, the magnitude of crystallization is greater than the magnitude of dissolution. Alright, so that is the supersaturated solution. Alright, next one, the unsaturated solution. We have here again the solute, and then we have here the solvent. So what happens here, the same thing as the one that you have seen on the saturated solution, but the difference is the solute is completely gone at the end of the day. All right, so what happens here, all throughout the process here on the unsaturated solution, the dissolution process is greater than the process of crystallization. Alright, so that is why the solute will not have any more chance to crystallize in this process, because it is now part of the solution, and it is being dissolved by the solvent. Okay, so that is the unsaturated solution. Okay, next one. Okay, so to better visualize what is saturated and unsaturated and supersaturated solution is all about. All right, let's put it into a daily life application. Okay, let's take a look at this. Right, so I have right here the. All right, you can visit their website. I will just put it in the link in the comment section. All right, so Texas Gateway. So this is an online resource. So thank you for that one, Texas Gateway. All right, so in this process, we will going to prepare a tea. And on preparation of the tea, we will use the unsaturated, saturated, and supersaturated as an example. Alright, so the first time that you prepare a tea, alright, if you don't like the taste of your tea, you put sugar on it. And you notice that all the sugar has been dissolved in the process. Alright, but you are not satisfied with the taste, then you put another packet of sugar. Right, so this time, it is not completely dissolved. There are more sugar, or there are sugar that remains at the bottom of your tea. Alright, and you are not still satisfied with the taste of your tea. You put a third packet of sugar. Alright, and by putting the third packet, you expect that it will not be completely dissolved at the end of the day. So the thing here is, what are you going to do in order to dissolve that extra sugar that you put on your tea? Okay, so if you have a guess in mind, yes, you are correct. Okay? You will be able to you will be able to dissolve those extra sugar and be part of this solution. Alright, only by boiling it. But if you don't boil it, it will be completely undissolved at the end of the day. Alright, so basically, that's how you make a type of solution or a kind of solution there. So what is a kind of solution that you did on that situation? Okay, so let's have number one. Okay. So in the process of adding one packet of sugar and you notice that there are no dissolved substances or dissolved sugar after you stir it, so that is that is an unsaturated solution. All right. So the keyword there is none. Alright, none of the sugar particles settled at the bottom. So please take note of that. Alright, so the second one, alright, if you put another sugar packet and you notice that there are sugar particles that remains at the bottom, so it might likely to be a saturated solution. Alright, and on the third part, now, in order for you to dissolve all the sugar that you put on your tea, all right, in order for you to dissolve all that sugar, you will boil the tea together with the sugar on it. All right. So, at the end of the day, because of the temperature increase, the sugar has been dissolved, so it will become a supersaturated solution. All right. So these are the three things that you need to understand how the different types of solution. What are the differences between these types of solutions that you have right here? All right. So there are a lot of ways that are not mentioned here. You can also do several things aside from boiling in order to achieve a supersaturated solution. Okay. So let's go back again to. Okay, so let's go back again to our main presentation. All right, so we have another one here, which is called another term, which is usually used in solution. We have miscible and immiscible solution. When we talk about miscible solution, so miscible solution is a type of or a kind of solution, or this is a kind of liquids. Alright? So this is the kind of liquids that when you mix them, you cannot tell which is which. Alright? So, for example, we have ethanol and water. So, meaning to say, the end product, the solution itself is somehow is somehow telling you that that is the final solution that you have right there. Okay, you cannot tell which one is greater, the ethanol or the water to ethanol, or which vice versa. Okay, meaning to say that these two, when you mix them together, they are combined. All right, they are combined uniformly. Right, they are combined uniformly, and you can't tell the difference on the final solution. All right. I repeat, the example here is the ethanol and water. Alright, next one. Another term to call those liquids that you cannot mix is called immiscible liquids. Alright, when you mix these two liquids, they will not dissolve each other. Alright, they will not dissolve each other. It's because one of them is has a structure that you cannot dissolve. All right, that you cannot you cannot dissolve by ordinary water, in which you will going to use another substance in order for it to dissolve it. For example, we have oil and water. All right, still the water is the universal solvent and the oil is your solute. Now in this case, you cannot dissolve the oil on water unless you have soap. All right, unless you have soap, it breaks the surface tension of the oil, and it allows the oil to mix in water. Alright, so this is the miscible and immiscible liquids. Okay. Next one is the concentration. So as I've said earlier, so the concentration is the ratio between solute and solvent in a given solution. All right. So the texture or the characteristics or the physical appearance of your solution will tell you what kind of concentration is that. Concentration on that solution is present there. Okay, so we have one here called concentrated solution. Then on the second one, we have a dilute solution. So in a concentrated solution, there are a lot of solute than solvent. Alright, in a diluted solution, there are small amount of solute than solvent. Alright, so if you happen to prepare a juice drink, if your juice drink ends on this kind of color, dark color, it means that your juice drink is concentrated. But if you prepare a color like this or a juice drink that has a color like this, it is somehow diluted. Alright, so that is the solution concentration. Okay, so furthermore, in order to mathematically, in order to prepare a correct amount of concentration in your solution, we use these particular formulas that we have right here, the percent by volume and then the percent by mass, in order to prepare a uniform solution which you can use in your experiment and other situation. All right, so let's start first with the percent by volume. The percent by volume is the volume. Alright, is the volume of solute. Alright, it's the volume of solute present. Alright, present in 100 ml of solution. Alright, so the base value here is 100 ml. Alright, so it has a formula. Percent by volume is equal to volume of solute in ml. You can have this one in liters in some situation, but if it is different, you change the other one. All right, you change the other one with appropriate units. All right, and divided by the volume of solution also in ml. All right, so we have times 100. All right, so that is the percent by volume. So the next one is the percent by mass. This is the mass of solute. Alright, so this is the mass of solute present. Alright, present in 100 grams of solution. So suppose you have a 100 grams of solution. The question there is how many grams of solute is present on that 100 gram of solution. This is the base value that we have right here. Now, in order to compute that one, or in order to mathematically solve that one, percent by mass is equal to mass of solute divided by mass of solution times 100. Right? So, to get the solution is equal to solvent plus solute respectively. Alright, so let's put these formulas to good use. Alright, so let's have a sample problem. Okay, now in this example, okay, if you're going to analyze it, you will be able to see, analyze that there are two entities that we have right here. Number one, we have, okay, so we have the ethanol over here, and the other one is this 250 ml. What is this 250 ml? Alright, so if you're going to read, what is the percent by volume concentration of a solution in which 75 ml of ethanol is diluted to a volume of 250 ml. Alright? So, what is this 250 ml? So, we all know that this 75 is your solute. Alright? This is your solute. Alright, so where's this ethanol dissolved? Probably in water. Alright? So this 250, what is this one? So, this one is dissolution. Alright, so this is the volume of the solution that is prepared already. So the question here is, if you will prepare a 250 ml solution, what is the percent by volume of that solution? Okay, so we have it right here. Okay, so what we have right here is the formula. So percent by volume is equal to the volume of solute over volume of solution. Right, times 100. Okay, so if you will punch this, if you will punch all the values here, 75 over 250 ml. All right, so you will cancel this one, and then you will have your percent. So the at the end of the day, you will be able to compute 30%. All right, so 30%. So what is this 30% all about? This is the percent by volume of an ethanol solution. Alright, so this is the percent by volume of an ethanol solution. Okay, so that is the answer on our sample problem number 1. Okay, so next one. Okay, let's take a look at this number 2. What is the volume of the acetic acid present in a bottle containing 350 ml solution which measures 5.00% concentration? Alright, so what do we have right here? Okay, so there is a solution, a volume of solution. So this is the solution. And we have, alright, so we have this 5% over here is the, okay, percent by volume. Alright, so this is the percent by volume. So we are looking for, alright, so we are looking for the volume of the solute, which is the acetic acid. Okay, so what is the volume of the acetic acid? So in order to compute for that, so let's have the formula again. So percent by volume is equal to volume of solute over volume of solution times 100. Okay, so in this case, we will have, okay, so we can get volume of solute by multiplying percent by volume times volume of solution. Alright, so this is already 100%. So this we will now incorporate the 100 here. Okay, so by solving by computing this one, you will have, alright, so you will convert this one into a decimal format, so 0.005, alright, times 350 ml. Alright, so 0.05 times 350 ml, you will get an answer of 17.5%. Alright, 17.5% is the volume of acetic acid. Alright, so this is the volume of the acetic acid in a solution. So I forgot the in a solution. Okay, there you go. So that is sample problem number 2. Okay, next, we work on for the sample problem number 3. Alright, so in order to find, alright, so find the percent by mass in which 41 grams of NaCl is dissolved in 331 grams of water. Now, in order to find the answer to this, right, so we are, okay, so we have here the keyword, it is percent by mass, right? We are not working on a percent by volume problem, okay? So in this case, we have, okay, so what is this 41 grams all about? So this is the solute, and this is the solvent. Okay, this is the solute and this is the solvent. So what is the formula here? So percent by mass is equal to mass of solute, right, over mass of solvent. Okay, times 100%. Okay, so what do we have here? Okay, so we'll put all those values here. We will substitute it on the equation that we have right here. So we have 41.0 grams, all right, of NaCl. All right. So since we have a this solution. Okay, so since we do not have any, we do not have a we do not have a final mass of the solution, we will going to use the solution is equal to solvent plus solute. So we can have 331 grams of water plus 41 grams of NaCl. Alright, times 100 is equal to Alright, so it is equal to, so if you do the math correctly, the answer here will be 11%. So the solution is 11% by mass salt solution. Okay, so 11% by mass solution. Okay, so that's the answer on problem number 3. Okay, next, number 4. Okay, so a dextrose, alright, which is called the D-glucose C6H12O6, alright, solution with a mass of 2.0 times 10 to the negative 2 grams and has 15.8 grams of dextrose dissolved on it. What is the mass percent of the solution? So this example is pretty easy. If you know already how to deal with scientific notation values, so this one is not will not give you difficulty. All right, so let's take a look. So the solution has a mass of this one according to the problem. So this is the mass of this solution. And what you have right here is the 15.8. Alright, so this is the 15.8 and this 15.8 is your solute. Alright, so the question here is what is the mass percent, alright, of the solution. So we are looking for mass, percent by mass on this problem. Okay, so we will use again that same formula. So percent by mass is equal to mass of solute. Alright, so mass of solute over mass of solution times 100%. Okay, so if you put the values here, so we have mass of solute. So we have 15.8, 15.8 grams, alright, of dextrose. Right, dextrose, and divided by 2. Alright, 2.00 times 10 to the 2 grams of dextrose solution. Right, times 100. Right, so just do the math properly. Alright, so just do the math here. You will get 0.079, I think. 0.079. Alright, and you multiply that with 100%, you will get 7.9%. Alright, so what is this one? Okay, what is this one? 7.9% is the percent by mass. Alright, so percent by mass of a dextrose solution. Right, so this is the answer here. 7.9% by mass of a dextrose. This is the percent by mass of a dextrose solution. Okay, so that is example number 4. All right. The last one, all right, for our last example that we have right here, example number 5. What is the amount? All right, what is the amount in grams of hydrogen peroxide is needed to make a 6 kilogram, alright, 3% by mass hydrogen peroxide. So this is a hydrogen peroxide solution. Alright, so what do you have right here? We have the mass. Okay, we have the mass of what? Alright, this is the mass of your hydrogen peroxide solution. And the percent by mass that you will going to prepare is 3% by mass. So the question here is how many of the solute, how much of the solute is present in your solution. Alright, so we will going to use again, or we will find out the mass of solute that is missing on this problem. Okay, so we will use the formula percent by mass is equal to mass of solute over mass of solution. And don't forget times 100. Alright. Okay, so what is the mass of the solute? So there's none. Right? That's the one that we are looking for. And there's a mass percent by mass and there's a mass of solution. So technically, we can use this formula mass of solute is equal to percent by mass times mass of solution. Alright, so in this case, the percent by mass is 6 kilogram. We can change this one. Alright, we can change this one into grams. So basically, this is 6,000 grams. Right? Sorry for that. So 6,000 grams, and that will be multiplied to the mass of the solution. Alright, so the mass of, this is the mass of the solution, and the percent is 3%. So that will be 0.3%, 0.03 in decimal form. Alright, so basically, whether you change them or not, it will arrive at the same answer. Alright, with of course with different units. Now, if you use kilogram, alright, if you use kilogram, if you do the math correctly, that will be 0.18 kilograms. Alright, 0.18. But if you use gram, you have 180 grams. Alright, 180 grams of H2O2 is needed to make a 3% H2O2 solution. Alright, so there we go. This is the final, I removed the one. Alright, so this is your final answer. Alright, so that will be the last example that we have right here. So just practice. Alright, so just practice a lot. Alright, you will be able to get this particular problem using the formulas that we have right here. So just understand how this formula works, right? Just understand how this formula works in your particular problem. Right? Just identify if it is a volume or a mass. There's already an indicator. If it is a mass, you have it in grams. Alright? And there's an indicator that it can be a volume because of the unit that you have right there. Alright, so basically, that is our discussion about what is a solution. Okay, it's concentration. Alright, it can be diluted or concentrated. Alright, so some liquids are miscible and some liquids are immiscible when you mix them. Okay, and also there are types of solution, which is the saturated, supersaturated, and unsaturated solution. Alright, so with that, so if you gain value on this video, if you learn something on this video, so don't forget to hit the thumbs up on this video down at the bottom. Alright, so if you want more videos, if you want more videos in the future, just like and subscribe, just subscribe and hit the notification bell on this video. Alright, it's in there at the bottom. And if you want to ask something, alright, if you want to suggest something that you want me to create or a video that you want me to create in the future, or a lesson that you are having hard time of, so just put it down in the comment section. All right, so that's it for today, guys. So let's see each other on the next science video. All right, so peace out.